Hi guys, welcome back. Today's topic is about the midpoint. We're in Unit 1, Day 4. The objective is I can determine the midpoint or endpoint of a given segment. So we're about halfway through our unit now. In the future, we will talk about distance formula and the equation of circles. The statement of inquiry for today is using coordinate planes to identify and analyze spatial relationships, provide insight about the world so that we can make and use them to make informed decisions. So I want you to imagine a school, and during lunch, Abby goes and visits Mr. Sylvia. At the same time, Andrew is in the cafeteria. Now, Abby and Andrew both have the same class right after lunch, and they agreed to meet up before going to class together. Where would you recommend that they meet? And why would you envision that particular spot? And how could you prove that a specific location was the best place to meet up? I imagine a lot of you guys are thinking kind of along the lines of, well, they can both start heading towards each other, meet at a point in the middle, and then go to class together. So that is one example of when finding the midpoint or finding the center point of something can be particularly useful. There are a lot of times when finding the middle or the center is necessary. Can you think of other times in your life where that has happened? Some are kind of silly, like maybe you're cutting a cake and you want the cake to have equal parts. You want everyone to have a fair slice. Deciding where to meet. Art. A lot of times in art, there's a very particular reason why you would want to have something in the middle or the center. One reason might be in creating perspective, like these 3 drawings over here. They're called buildings in 1-point perspective. Maybe you're building something and it has to be in the center so that it can be balanced, kind of like a seesaw. When you're taking pictures, you usually want the person or the main focal point to be in the center, or if it's not in the center, for you to have a rationale behind maybe why it's not, right? When you're playing sports, basketball, soccer, football, there's a lot of angles and precision that goes into that. A lot of times, getting it right in the middle of something. But there's also maybe more philosophical reasons, like making a compromise. Right? How does both sides give in a little bit so that they can come to a group consensus? Things like this all go into this idea of finding the center or the middle. And we're going to learn how to do that in math today. So, midpoint is the exact center or the exact middle of a line segment. Now, recognize here that we're talking about line segments, which means we have endpoints. Right? If we have a line where they go on forever and ever in both directions, we'll never have a middle point, right? So in a line segment where we have defined endpoints, it's possible to calculate the exact center. And we do that using the midpoint formula. You have x1 plus x2 over 2, comma y1 plus y2 over 2. Now, realize that when we're talking about the midpoint, we're talking about a specific point. So your answer for the midpoint should always come in the form of a coordinate point, which means we have our parentheses, your x value, comma, y value, parentheses. Your answer for the midpoint should always come in that form, all right? Here, your x's and y's represent the endpoints, right? And so you take your x values, you add them together, divide by 2. Your y values, add them together, and divide by 2. In essence, you're finding the average of the x values and then the average of your y values. All right? Just to reiterate, the endpoint is a point that marks the end of a line segment or array. So here we have our endpoints right over here. Okay? All right, so our first teacher example. Our friend Emily is at the carousel. And our carousel, I'm just going to highlight for us, is right there. And Eric is at the haunted house, which is right here. Emily and Eric's mom says a roller coaster is the exact midpoint between Emily and Eric. Your job is to figure out if their mom is right. In order to do this, we're going to need to start out by figuring out the coordinate points of the carousel and the haunted house. So here, I'm going to write a C for carousel. And if we look, we have our very origin center here. We go over 10 and then 1, 2, 3, 4. So this is a coordinate point for the carousel. Our haunted house, I'm going to label with an H, is at 0, and then it's going to be 1, 2, 3, 4, 5, 6, 7. -7. And then the roller coaster that Mom said was exactly at the middle is right there. So I'm going to use R for roller coaster, and that's at 4, and then down 2. All right. So if we imagine our line segment here, I'm going to go just like that. You can see that our endpoint is a haunted house and the carousel. So those are the values that we would plug into our midpoint formula. So I'm going to label x1, y1, x2, y2. And then I'm going to write out our midpoint formula is parentheses x1 plus x2 over 2, y1 plus y2 over 2. All right, now that I have my x1, y1, x2, y2s, I can plug them in and see if my calculated midpoint happens to be the same as the roller coaster or not. So x1 is 10 plus 0, and then our y1 is 4 plus, and then -7 here. All right, so 10 plus 0 is 10 over 2. And then 4 plus a -7 is a -3 over 2. And then simplifying that, we get 5 comma -3 halves. And as you can see, those are not the same. So while Mom is pretty close, they're close to the midpoint, the roller coaster is in fact not the exact center. So determine if their Mom is correct. No, Mom is not correct. The exact actual center would be right over there. All right. So try your own student example. All right, teacher example number 2. Now we're given a midpoint and an endpoint, and we're looking for the other endpoint. So I want us to recognize the difference between this kind of problem and the one that we just solved. In the previous question, we were given the coordinate point for both endpoints. We knew exactly what the endpoints were, and we were looking for the midpoint. You use the midpoint formula when you're solving for the midpoint. Here, however, we're given the midpoint and an endpoint. We're looking for the other endpoint. And when that's the case, we're going to organize our information like this. Here's our endpoint. Here's our midpoint. And then we're going to be looking for our other endpoint. And what we know about this is if we had our endpoint, midpoint, endpoint, we know that the distance in the x direction and the y direction to the midpoint will be the same distance, x direction, y direction, from the midpoint to our other endpoint, right? So this is our change in the x, change in the y, change in the x, change in the y. What that means is if we think about, well, how does our x values change from endpoint to our midpoint? We're going from -9 all the way to 2. So that goes in the positive direction, how many units? If that's a little bit tricky for you to think of right off the bat, we can just draw a number line like that. We have -9 over here, we have 0 here, and then we have 2 right here. We're starting at -9, we're trying to get to 2. So from -9 to 0, that's a +9. And then from 0 to 2, it's a +2. You put those together, you get a +11. That means if we do -9 plus 11, we end up with 2. All right. because that distance remains the same, right? This change in x is the same as this change in x. We're going to apply that same pattern again. It's going to add 11. So it's going to be 2 plus 11 gets us 13. That tells us the x value of our second endpoint. And then we're going to do the same thing over here. So we're going to go from 12 and go to -4. Going from a positive to a negative number, so we know we're going to go in the opposite direction. We're going a negative direction. So again, here's my little number line, and then I have 12, 0, and -4. All right, and now we're going from 12, so to 0, it's going to be -12, and then from 0 to -4, we get a -4. So put those together, we get -16, and again, we're going to apply that same change in y here, -16. So -4 minus 16 gets us to -20. So that tells us that our endpoint is 13, -20. Try your student example number 2 on your own. All right, teacher example number 3. After finding the treasure box, the crew eagerly opens the box. They're disappointed to find the note that has the following note scrawled on it. The treasure you seek is elsewhere. Go to the pirate telescope, then continue that distance once more. Where is the actual treasure buried? So, if you look in our map here, they went to where X marked the spot, they dug up their treasure box, and they found the note. It says, from where you're standing, go towards the pirate telescope. So that's going to be here, right? Go that distance. And this says, continue that distance once more. Like that. And you need to figure out, where is the exact location of this treasure buried? In order to do that, we're going to need to figure out the coordinate points of wherever X marks the spot, as well as the pirate telescope. And then we know that the pirate telescope is the midpoint, right? Because we have to go that same distance again. Then we can use the same strategy that we used in our second teacher example to figure out where the treasure is actually buried. So here, X marks the spot. We have 1, 2, 3, 4, and then we go 1, 2, 3, 4, 5. So X is at 4, -5. Now our telescope here, we'll label that with a T, is at 1, 2, 3, 4, 5, 6, and then down 2. And then here, we'll call it just our other endpoint. This is where the treasure is actually buried, right? And that's what we're looking for. So to go from 4 to 6, we're adding 2, which means we're going to add 2 here. So 6 plus 2 is 8. Here, we're going to go from -5 to -2. So you have a very negative number becoming less negative, which means we're going in the positive direction, 3 units. I'm going to do that one more time. -2 plus 3, we get a +1. That means our treasure is at 8, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 1, right there along the beach. And that's where our treasure is going to be buried. Use a similar strategy and then solve student example number 3. All right. Just like all the previous lessons, in your summary, we're expecting 3 to 5 sentences where you really think and analyze what is the new information you've learned, what is the most important pieces of information that you've learned. Additionally, I want you to think about what our statement of inquiry was. And make sure we're using our proper academic vocabulary. All right, thanks for listening, you guys.